In our last video, we began to look at how we can simplify radicals. That simplifying of radicals is going to allow us to add and subtract radicals as well. To set this up, though, I first want to consider how we would simplify something like 2x plus 3y minus 4x plus 5y. In this case, we would notice the like terms of 2x and negative 4x give us negative 2x, and the like terms of 3y plus 5y would give us a positive 8y. We can follow a very similar pattern with radicals. What if the problem instead was 2 root 3 plus 3 root 7 minus 4 root 3 plus 5 root 7? Notice the difference here is we have root 3 instead of x and root 7 instead of y, but the logic is still the same. If I have 2 of these root 3's and we took 4 of them away, there are now negative 2 of these root 3's. Similarly, if there's 3 of these root 7's and we add 5, now there's 8 of these root 7's. In other words, when working with radicals, just like when working with variables, we can combine like terms by adding the front numbers. And notice when we did that, when we did 3y plus 5y to get 8y, the y's did not change. Similarly, 3 root 7 plus 5 root 7, we get 8 root 7. The root 7 did not change, just the number of those root 7's that we had. So for example, if I have negative 4 root 6 plus 2 root 11 plus root 11 minus 5 root 6. If I want to combine like terms to simplify this, I see negative 4 and negative 5 of these root 6. Add that together to get negative 9 root 6. I also see 2 plus 1 of these root 11's gives us a total of plus 3 root 11, and that becomes our simplified expression. But where this becomes really nice and combines with what we saw in the previous video is if I have something like 5 root 50x plus 5 root 27 minus 3 root 2x minus 2 root 108. That might look on the surface like there's no like terms that I can combine. But look what happens when we simplify each of those radicals. 50 is 2 times 25, which is 5 times 5. And so that first radical is really 5 times the square root of 5 squared times 2x. The second radical, pull out a 3, leaves behind 9. Pull out a 3, leaves behind a 3. Means we're adding 5 times the square root of 3 cubed. Minus 3 root 2x. There's not any simplifying we can do there. But with the 108, 108 is 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3, making sure I circle all those primes. And so we end up with minus 2 times the square root of 2 squared times 3 cubed. All of these squareds we can pull out. So 5 squared pulls a 5 out, and 5 times 5 is 25 root 2x. Plus 3 to the third power allows a single 3 to come out, leaving behind a 3. 3 times 5 is 15. Minus 3 times the square root of 2x. Minus 2 squared comes out as a 2. And 3 cubed pulls a 3 out, leaving behind 1 3 behind. And so 2 times 2 times 3 is 12. And now when I look at this, I do have some like terms I can combine. We have 25 root 2x and negative 3 root 2x. 25 minus 3 is 22 root 2x. And then I have 15 square root of 3 minus 12 square root of 3 leaves behind 3 square roots of 3. And we've got our final answer. By simplifying the radicals first and then combining like terms, we can add and subtract radicals. Our next video is going to take a look at how we can multiply radicals.